Hi, and welcome to section 6. In this section, we will learn how to perform important system maintenance. In this very first video, section 6, we are going to learn how to monitor the system. When we talk about monitoring the system, the first thing that often comes to mind is monitoring the system itself, such as the CPU, RAM, and storage usage, as well as maybe the network usage. But we can also monitor things like I/O performance, that is, data input and output to and from our hard drives. And also to monitor our network security. The first step to do this is to list open ports, so that we know which daemons are listening for network traffic. Let's begin with monitoring the CPU usage and memory usage. There is a really great tool for that comes with all Linux distribution, and it's simply called top. So, just type top. At the very top of the screen, we first have the uptime, that is how long the system has been running. We then have number of logged in users, and then we have something called load average. And that is how heavily utilized the CPU is in the last minute, the last 5 minutes, and the last 15 minutes. Interpreting these numbers can seem a bit awkward at first, since they are not percentage values. But it isn't too difficult after all. Basically, what these numbers mean is this. This will all be a bit oversimplified, but it will nonetheless teach us how the load average is calculated. And don't worry, this won't be a tedious math lesson. Anyhow, a load average of 1.0 means that one process is utilizing the CPU core at 100% on a single core system. It could also mean that there are two processes, for example, each one utilizing the CPU at around 50%. A load average of 3.0 can mean that there are three processes, each working at 100% and thus competing for a single core. Just to give another example, it could also mean that we have 6 processes running on the system, each at around 50% utilization. Likewise, a load average of 0.5 means that, for example, there are 2 processes, each running at 100% of a 4-core system. In other words, the system is only utilized at half of its potential. And once again, another example would be 4 processes working at around 50% each on a 4-core system. And once again, it's only utilized to about 50% of its potential. And one last example, a load average of 0.13 could mean that we only have a single process running at 100% on an 8-core system. Or, why not, 2 processes each running at 50% on an 8-core system. And if we go a bit further down, we have the total memory utilization on the system. By default, this is in kilobytes, which can be really hard to read on a system with several gigabytes of memory. So, to change this into megabytes or gigabytes, just type a capital E. It now turned into megabytes instead. Type another capital E, and it turns into gigabytes. And one more will switch to terabyte. And one more will switch to petabyte. And then we have exabytes. And one more will go back to kilobytes. I like to have mine on megabytes, so I will leave mine here for now. Then we have the list of processes and their corresponding CPU utilization and memory utilization. Per default, this list is sorted by CPU utilization, where the process using the most of the CPU is displayed at the top. Once again, the display of memory is in kilobytes here, in the memory column. To change these 3 columns here to megabytes or gigabytes instead, type a lowercase e. And now we have it in megabytes. To change which column to sort by, first type a lowercase x. This will highlight the column which top sorts by right now, and right now this is the CPU column. To change sorting column, we use the greater than symbol to go right, and the less than symbol to go to the left. Like this. I go left, and I go right. Notice how the bold white column changed as I pressed the keys. So now the process is instead sorted by memory utilization. And that was top. It's now time to move on to some other useful tools. To quit from top, just hit Q as in quit. The next tool I will show you have to be installed, and it is called I/O top. It is a similar tool to top, but this one is only for I/O, that is for disk writes and reads. The package is called I/O top across all distributions, so install it with the package manager of your distribution. For example, in my case this will be yum install I/O top. Or if you're using Debian or Ubuntu, you use apt get install I/O top. Then you simply start it with I/O top. And as you can see here, we need to run it as root. To change the sorting column here, we instead use the left and right arrow key on our keyboard. Here I select the disk write column. If I now start a process that will write a lot of data to the disk, it will show up here at the very top. Like this. At the very top we see a summary of the total and actual disk write. And then at the very first line we see which process is actually write to the disk right now. And in this case it is the command dd. And quit by hitting a Q. And let's clear the screen. The next tool will help us to monitor the network traffic to and from our server, and it is called iptraf. This tool will also need to be installed. Same thing here, the package name is iptraf on all systems. So in my case this will be yum install iptraf. When we run the program though, it must be started with the command iptraf-ng. And it must also be started as root, so sudo iptraf-ng. We are now presented with a nice console-based graphic interface. And from here I select the first option, IP Traffic Monitor. And I select all interfaces. Right now I only see my own SSH connection here, which is currently running wild every time there is a screen update. That data is transferred over the network, resulting in another update and so forth and so forth. But if I access the web server running on this machine from another machine, you will see it show up here. There you see it. So every time I update the page, the packages will increase. This can be very useful to find out what traffic is going to and from this machine right now. To exit from iptraf, hit X. And another X. And we're outside again. And let's clear the screen. Now it is time for another tool. This one will list established connections as well as which ports are open and listening for traffic. This tool is included in all distribution and its name is SS. Now to view listening ports, both TCP and UDP, we run SS-T for TCP, U for UDP, and L for listening. This can seem a bit cryptic at first. NetID is which protocol it is, for example UDP or TCP. State is in which state it is, for example listening for TCP connection and unconnected for UDP. For all intents and purposes, this is the same. UDP is a connectionless protocol, and therefore it has a different name. The next important field is local address and port. Let's take this entry here, for example, 127.0.0.1:SMTP. 127.0.0.1 is the IP address for the local host. That means that this is a local machine. And since this service is only listening on this IP, that means it is not reachable from the outside. After the colon we have SMTP. This tells us that this is an SMTP server, a mail server in other words. And then down here we have :1:SMTP. :1 is the IP version 6 equivalent of 127.0.0.1. That is the local host address. And then we have peer address and port over here, which is actually only important when we later view established connections. If we have a look at this entry here, *:SSH, or an asterisk that is also called, an asterisk here, or all zeros, means that this service is listening on all interfaces and all addresses, and thus it can be reached from the outside of this computer. So, this one is listening for incoming connections on the network. And as you might have already figured out, SSH means just that, SSH protocol. This can look a bit different on different machines, and also if it is an IP version 4 only service, or if it is listening only on IP version 6, if it is listening for both IP version 4 and IP version 6. Here are a couple of examples. All of these examples, though, means that the service is listening for outside connections. That is, other computers can connect to this port. So, for example, this one is listening for IP version 4, and this one is listening on IP version 6. : means the same thing as an asterisk, but instead for IP version 6. So both this and this means that the services is available to the outside. This one is listening on incoming connections on IP version 4, and this one is listening for incoming connections on IP version 6. Also notice that this can also be the real IP address of the machine. For example, 192.168.0.46:SSH. That would mean that the SSH service is listening for incoming connections on the network interface which has that IP address. But then we have our web server. Here is only an IP version 6 address : and : HTTP. But we know that this is listening on IP version 4 also, since I was able to reach it on 192.168.0.46 in the previous section. How come? Well, it actually maps over to IP version 4 as well. All of this can take some time while getting used to, but this is a good start. If I switch over here to my Ubuntu machine, you will see it looks a bit different here. For example, here I also see which interface is being used. For example, %LO means the localhost interface, %ENF3 means the interface card ENF3. And instead of just a star for the SSH service, we have 0.0.0.0, which is exactly the same as the star we saw in CentOS. Another different thing is this. The address here is enclosed in square brackets, so that we can actually see the difference between the address and the port. It is also possible to view established connections with SS. Just leave out the L in the options to SS, and it will instead only list established connections. For example, SS, T for TCP, and U for UDP. Here I see that I have 3 established SSH connections to this machine from this IP address here. So the IP address over here is a machine that is currently connected to my machine over SSH. The port number shown here is what's called the source port, and that will always be a very high and random port number.